Hello students, welcome to Techno Science Club. In today's class, 10th class English medium, classification of elements on the periodic table, the properties of elements law, part 2 law, ionization energy and the factors depending by the ionization energy. ఈ టూ టాపిక్స్ని ఈరోజు మనం క్లాస్లో నేర్చుకుందాం. ఈ వీడియోని పూర్తిగా చూడండి, లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయడం మాత్రం మర్చిపోకండి. లెట్స్ గో ఇంటు ద టాపిక్. Welcome back friends, welcome back to Techno Science Club, welcome back to 10th class English medium, classification of elements on the periodic table. In this lesson, properties of elements, law, ionization energy. What is ionization energy and how the ionization energy is decreased or increased in the groups and periods, and what are the factors the ionization energy of an element depends upon. First of all, the definition for the ionization energy: the energy required to remove an electron from the outermost orbit or shell of a neutral gaseous atom is called ionization energy. Ionization is the energy required to remove an electron from the outermost shell, that means last shell of the atom. To remove one electron from the outermost shell or valency shell of an atom, a required energy to remove that electron from the outermost shell or valency shell is called, to remove the electron, that energy is called ionization energy. If you remove one electron from an element of outermost shell of an element, that required energy is called first ionization energy. If one electron removed from the outermost shell of an atom, that energy is called first ionization energy. And the energy required to remove electron from unipositive ion. What is the meaning of this unipositive ion? When you remove one electron from an atom, it becomes ion. What type of ion? Positive ion, because one electron is lost by the atom. One electron is removed by the atom. So the atom is transformed into positively charged ion. For example, sodium. If sodium has an atomic number 11, it will try to get the stability as neon, which contains 10 electrons. So the sodium will loses one electron, or one electron is removed from the sodium atom, and the sodium atom is transforms into the sodium particle, sodium ion, positively charged sodium ion. So one electron remove and the atom becomes positively charged ion. From these unipositive ion, uni means one electron is removed, one positive ion. So the unipositive ion, from that unipositive ion, another electron is removed. The energy required to remove another electron from the unipositive ion is called second ionization energy. So if another electron is removed, third ionization energy. If 4 electrons is removed, fourth ionization energy. In that type, the energy required to remove the electron from the outermost shell of an orbit, outermost orbit of an atom is called ionization energy. Here the M is the element and IE is the first, IE1 is the first ionization energy to remove one electron. So IE is called first ionization energy, and M plus represents the positive uni-charged ion. From these uni-charged ion, another electron is removed. To remove that electron, we required some energy. That energy is called ionization energy 2, IE2, second ionization energy. So the second ionization energy of an element is higher than the first ionization energy. Yes, correct. Second ionization energy is higher than the first ionization energy because, for example, here the say take a sodium atom. Here you take sodium atom. You can take the sodium atom. In the sodium atom, you remove one electron and the sodium atom become sodium ion, positively charged unipositive sodium ion. There are IE1, ionization energy 1 is required. First ionization energy 1 is required. And from these Na plus unipositive ion, another electron is also removed. If the another electron is also removed, then it become Na2 plus. This Na2 plus is not allowed by the unipositive sodium ion. This unipositive sodium ion is not allowed to remove second electron from their atom. Why? Because the sodium wants to get stability like neon and get 10 electrons in the orbits, total orbits. So there is a total orbits, 10 orbits in Na plus unipositive ion. The Na plus unipositive ions is not allowed to take another electron, but we can take the another electron by using extra energy from the Na plus unipositive ion. So that extra energy is called second ionization energy. We can take the electron out by using more energy on the unipositive ion of sodium, right? These ionization energy of an element is depends upon the ionization energy of an element depends upon 5 factors. What are that factors? The first one is nuclear charge. What are that? Nuclear charge. And the second one is screening effect and shielding effect. And the third one is penetrating power of an orbital. And the fourth one is stable electronic configuration. And the fifth factor, atomic radius. On these 5 factors, the ionization energy of an element depends on these 5 factors. How these 5 factors affect the ionization energy? Let's see. First factor affecting ionization energy, the nuclear charge. What is the meant by the nuclear charge? You know, in the previous chapter and previous topics, the nucleus, which is contains positively charged protons. So the nucleus is also positively charged. And the electrons are revolving around the nucleus with a negative charge. So there is an attraction between the positive charged nucleus and the negatively charged electrons are there. So that attraction by the nucleus is called nuclear charge on an electrons. Nuclear charge on electrons. That attraction force by the nucleus on the electrons is called nuclear charge, right? If the more nuclear charge, if the nuclear charge is more, is the ionization energy is also more. More nuclear charge, more ionization energy. Why? Because there is a more nuclear charge. There is a more attraction between the nucleus and the electrons. So the nucleus is attracted by the nucleons. Electrons is attracted by the nucleus very strongly. The nucleus take care the electrons very effectively. In this situation, we can very hard to remove an electron from outermost shell of an atom. So the nuclear charge is more in that atom. The removal of electron is very hard. So we can remove that electron, but very hard. We have to apply more energy. So the ionization energy is also more if the nuclear charge is more. For example, in between the sodium and the chlorine, example, sodium atom, we can remove the electron from the sodium atom easily, but we cannot remove the electron from the chlorine atoms easily. We have to apply more energy to remove an electron from the chlorine. Why? Because in that chlorine atom, in the outermost shell, there are 7 electrons are there. The chlorine required 1 electron to stabilize themselves. So to get stability, chlorine required 1 electron, and the electrons in the outermost shell of the chlorine is 7. So the chlorine is not allowed to take 1 electron from him. So the energy is more required to remove from the chlorine. The sodium can remove 1 electron easily, but not chlorine. Chlorine cannot allow the electron to remove. He want to get 1 electron from the outer elements. వేరే ఎలిమెంట్స్ నుంచి అవుటర్ ఎలిమెంట్స్ నుంచి ఎలక్ట్రాన్స్ని గెయిన్ చేయడానికి ఎక్కువ ప్రిఫర్ చేస్తుంది క్లోరిన్. The chlorine prefers to gain 1 electron and get stability, but sodium loss 1 electron can give 1 electron and get stability. So we can remove 1 electron easily from sodium, but we cannot remove 1 electron easily from the chlorine, right? The second factor that affects ionization energy is scattering effect or shielding effect. If the more the shields with the electron between the nucleus and the valency shell, the ionization energy is decreases. Why? Because if there is a shields or screens, these shields or screens means orbits. If more orbits are there, if more shields are present, that means shields means here the shields means orbits between the nucleus and the outermost orbit. If the outermost orbit is the 5th orbit, there are 4 orbits are there in between the nucleus and the outermost 5th orbit. Outermost 5th orbit ki nucleus ki madhyalo 4 orbits untai. There are 4 orbits, that means 4 screens are there. So the attraction between the nucleus and the last 5th valency orbit is less, because there are 4 orbits behaves as a screens or shields to decrease the nuclear charge between the nucleus and the valency shell. So we can remove an electron easily from the outermost shell because of the less attraction between the nucleus and the outermost shell electrons. So if the screening effect is more, that valency, that is called screening effect. If the screening effect is less, ionization energy is more screening effect, less ionization energy. More screening effect more ga unte ionization energy less ga untundi. If the screening effect is more, the nuclear attraction is less, we can remove electron easily. But the screening effect is less, there are number of orbits is less, number of screens is less in an orbit, in an electron, in an element, we cannot remove easily electron from the outermost shell. Here the example lithium and the cesium. In lithium there is a second shell, last shell, valency shell is second shell. So we can remove electron, we cannot remove electron easily. Why? Because there is a 1 orbit in between the nucleus and the outermost second shell. Only ఒక్క shell మాత్రమే ఉంది, ఒక్క screen మాత్రమే, only one screen or one shield is there between the nucleus and the electron. But in cesium there is a 5 orbits are there in between the valency shell and the nucleus. Nucleus ki valency shell ki 5 screens are there in between the nucleus and the outermost shell. So the attraction between the nucleus and the outermost electrons is less in cesium. So we can remove electron from cesium very easily. So in cesium is more inner shells, more shields are there. So the less ionization energy in the cesium. So this is the second factor that affects. If the screening effect is less, ionization energy is more. If the screening effect is low, ionization energy is high. The third factor affect the ionization energy is a penetrating power. The penetrating power of an orbital means there is a 4 orbitals are there in the 10th class. There is more orbitals are there, but we can deal the 4 orbitals. That means S, P, D, F. In these 4 orbitals, more penetrating power has S orbital. S orbital has more penetrating power. Why? Because the S orbital, the first orbital is there, S orbital in the first shell. In the second shell or third shell or fourth shell, we can fill the electron in first shell, first orbital. Why? Because this orbital has low energy. So the S orbital is more near to the nucleus. So the S orbital having the more penetrating power. The orbital belongs to the same main shell but different penetrating powers. For example, 4s is greater than 4p is greater than 4d is greater than 4f. That means S orbital is more penetrating power, has more penetrating power than remaining orbitals. So in example, for the example, 4f electron, 4s electron, in these 2 orbitals, 4s is more penetrating power. Beryllium, we can take the example as a beryllium. In beryllium, 1s2, 2s2, and the boron, 1s2, 2s2, 2p1. So the element boron has a less ionization energy due to the less penetrating power of 3p. 3p is the last orbital of boron, but the last orbital of all of beryllium is S. So in beryllium, there is a more penetrating power is there. So the ionization energy is less for the beryllium. Penetrating power ఎక్కువ ఉంది కాబట్టి ionization energy is less. So in boron has a less ionization energy and beryllium has a more ionization energy, because if more penetrating power is there, more ionization energy is there. So beryllium, in beryllium there is a S orbital. So the S orbital has more penetrating power. That means it has more ionization energy. In boron, the last orbital is p orbital. It has a less than p, less than S orbital penetrating power low. So the boron has a less ionization energy due to the less penetrating power of 2p, right? So the penetrating power is high, ionization energy is high. Penetrating power is low, ionization energy is low, right? The fourth factor affecting the ionization energy is a stable electronic configuration. If there is a stable electronic configuration, there is no required to take electron or give an electron. It is easily to remove one electron from oxygen or nitrogen. Yes, this is because nitrogen stable half-filled configuration. Nitrogen has stable half-filled configuration. We can write this electronic configuration of nitrogen having atomic number 7, 1s2, 2s2, 2p3. So here you can observe that the last, the valency shell is second shell. It has electrons 5. If the last shell is completed, if p orbital is completed with the 6 electrons, it will be completely filled. But the p electron is half filled. If half filled is also having a more stable. If half-filled p orbital is also more stable than oxygen. So the stable electronic configuration is there, or half-filled electronic configuration is there, there is more ionization energy. So the last factor affecting the ionization energy is atomic radius. More atomic radius, less ionization energy. More atomic radius, less ionization energy. Therefore, the ionization energy of a fluorine is greater than the iodine. If you take the example for the fluorine or iodine, the ionization energy of a fluorine is greater than the iodine. Why? Because if ionic radius is less, ionization energy is more. Fluorine and iodine, take two examples. Fluorine has a less atomic radius because it has the 9 electrons only. 2 electrons first shell, remaining 7 electrons are second shell. So there is two shells are there. So it has a small atomic radius. But in iodine, there are more orbitals, more electrons are there. It accommodates more orbitals. So the ion atomic radius is also more. So the ionization energy is less. So atomic radius is more, ionization energy is less. We can also take the example as a sodium and a cesium also. Sodium has a 3 orbitals only, and the cesium has a 6 orbitals, 6 orbits. So it has a more atomic radius than sodium of cesium. So cesium has more atomic radius, so the less ionization energy. The sodium has a less atomic radius, so it has more ionization energy. So the ionization energy is decrease as we go into the groups. Groups flow from top to bottom, the ionization energy is decreases, and the ionization energy is increases from left to right in the periods. This ionization energy is represented by the units of kilojoules per mole. This ionization energy is also called as ionization potential. This ionization potential, right, electron volts atom square లో కూడా మెజర్ చేస్తూ ఉంటారు. సో దిస్ ఇస్ ద 5 factors that affects ionization energy. In this class you learn about what is ionization energy and how the ionization energy varies in groups and periods, and what are the factors that affects ionization energy. So these topics are learned in this class. If you have any doubts, you can write in the comment box. I will answer you definitely. So please like, share and subscribe and comment. Thank you for watching. We will meet again in the next class. Thank you for watching. Jai Hind, Vande Mataram.